All right, section 10-8, geometric probability. Okay. All right, so a point indicates a location and has no size. That's true. A line contains a finite number of points. That's false. It has an infinite number of points. All right, so use this diagram to right, circle the segment that includes point S, and that would be the segment PT. All right, so probability. The probability of events, the likelihood that the event will occur. So in geometric probability, favorable outcomes and possible outcomes are geometric measures such as lengths of segments and areas of regions. So the probability of an event is the ratio of the number of favorable outcomes to the number of possible outcomes. So here's an example. If there are 7 red marbles and 3 green marbles in a bag, 1 marble is chosen at random. What is the probability green is chosen? So we're going to first find green. There are 3 green out of a total of 10. As a decimal, it's 0.3, and as a percentage, it's 30%. All right. So point S is on the line segment AD and is chosen at random. The probability that S is on BC is the ratio of the length of BC to the length of AD. All right, so probability S is on line segment AC is equal to AC out of AD. Probability S is on AB is AB out of AD. Okay. Now, we can also do this in parts of regions. So, probability S is in N. Okay. Okay. We know the area of N is 3. We know the area of R is 11. Okay, so we want S to be in N, so point S is going to be in here. So favorable is going to be 3 out of a total of 11. All right, so number 1 here. So find the probability that point H is on ST. Select at random. What is probability H is on SR? So the entire thing is ST. We need to find the length of ST and then SR. Okay, so the length of SR is going to be 2 minus H, which is going to be 6. The length of ST is 2 minus 14, which is 12. So the probability is going to be 6 out of 12, or 1/2. So the probability that H is on SR is 1/2, or 50%. Okay. So a commuter train runs every 25 minutes. If a commuter arrives at the station at a random time, what is the probability the commuter will have to wait no more than 5 minutes for the train? So circle the T in minutes before the train arrives. The commuter will need to arrive in order to wait no more than 5 minutes. Well, this is the probability statement we want, no more than 5 minutes. Circle the diagram that models this situation. This is what we want, no more than 5 minutes. So the length of the favorable segment is 5. The length of the entire segment is 25. So the probability is 5 over 25, which is 1/5. So the probability the commuter will not have to wait more than 5 minutes is 1 out of 5, or 20%. All right, let's use areas now. So a triangle is inscribed in a square in point T. Point T, this is inscribed. Okay, so point T is in the square, selected at random. What is the probability T lies in a shaded region? All right, so first thing we need to do is the area of the shaded region we're going to call S. Area of the square is going to be then S squared minus the area of the triangle, which is 1/2, 5 times 5. Okay. So we have S equals 5 squared minus 1/2 times 5 times 5, which is 25 minus 1/2 of 25, which is equal to 25 minus 12.5, which is equal to 12.5. So the probability is going to be 12.5 divided by 25, or 1/2. So the probability that T lies in a shaded region is 1/2, or 50%. Okay. So an archery target has 5 scoring zones formed by concentric circles. The target diameter is 122 centimeters. The radius of the middle zone is 12.2 centimeters. The width of each zone of the other zone is also 12.2. If the arrow hits a target at the random point, what is the probability it hits the middle zone? So the radius of the target is 122 divided by 2, or 61 centimeters. Find the probability. So pi times 12.2 squared over pi times 61 squared, which is going to be 148.84 divided by 3721, which equals 0.04. Okay, explain why the calculation with pi is not estimate. Okay, I divide pi out before finding the quotient. So notice the pi's cancel there. So that's why this is not an estimate. It's exactly equal. So the probability the arrow hits the middle zone is 0.04, or 4%. Okay, so in the figure at the right, SQ over QT is 1/2. What is the probability a point on ST is chosen at random will lie on QT? And explain. So if SQ is X, then QT is 2X, and ST is going to be 3X. All right, so 2 divided by 3, because the 2X over the 3X equals 2 over 3. Done. And that's the end of this section.